Uranium is a metal found in most types of rock. Like coal, oil and other fuels, it must be processed before it can be used in a power station to produce electricity. Uranium mining takes place in both open-cut and underground mines. The uranium mines in China supply the fuel for the nuclear power station at Daya Bay. The uranium ore is first crushed to a fine powder, then separated from the rock particles by a chemical process. It is purified, producing uranium oxide, commonly known as yellow cake. This yellow cake is sent to a conversion plant, the first stage of a circular journey in which the nuclear fuel goes through enrichment, fuel fabrication, power generation, spent fuel storage, reprocessing, and then back to conversion, where the cycle begins again. The conversion plant changes the yellow cake into uranium hexafluoride, which is sealed into special containers, solidified and sent to an enrichment plant. Here, the percentage of uranium-235 in the converted uranium is raised from 0.7% to 3%, making it suitable for power station reactors. Atomic weapons require enrichment to about 90%. In the fuel fabrication plant, the enriched uranium is formed into pellets, which are placed end to end into some 40,000 fuel rods, which are then sealed at both ends. The rods are assembled into 157 fuel assemblies, which form the core of each reactor. The fuel assemblies are then placed inside specially designed casks and transported in accordance with international regulations to Daya Bay. They are then placed into the fuel storage pool in the nuclear fuel building until loading into the nuclear reactor takes place. With the fuel loaded into its reactor, the station will commence the commissioning process. After having obtained the necessary license from the National Nuclear Safety Authority to verify that the station meets all the stringent safety and environmental standards, it will then start producing electricity for Guangdong and Hong Kong. Each year, 1/3 of the fuel assemblies inside the reactor are replaced. Reloading takes place during reactor shutdown periods. Fuel assemblies that have been in the core for 3 years are removed. Those remaining in the core are moved towards the center, and the new fuel assemblies are then installed on the outside. In order to gain access to these used or spent fuel assemblies, the cover of the reactor is removed. The space above it is then flooded with demineralized water. This will shield the operators from radiation. The highly radioactive spent fuel, which has been removed from the reactor core, is passed through a transfer tube to the spent fuel storage pool. This pool is large enough to store up to 10 years' production of spent fuel. It also allows the heat of the fuel to dissipate in the water and the radiation to decay. When the time comes for its removal, the spent fuel is loaded into heavily shielded containers or casks for its journey to the reprocessing plant. This is the last stage before it completes a full circle. At the reprocessing plant, the used fuel is cut into small pieces and dissolved in acid. After the separation process, 96% of the uranium can be recovered, while the radioactive waste is vitrified and transported for long-term storage. The recovered uranium is then sent to the conversion plant, and the nuclear fuel cycle begins all over again.